This video, we're going to look at the solutions to the Chapter 3 practice test over describing relationships. This video should cover the first 5 multiple choice, and then we'll do the next 5, and then the free response in the third video. So for problem 1, a school guidance counselor examines the number of extracurricular activities that students do in their grade point average. The guidance counselor says the evidence indicates that the correlation between the number of extracurricular activities a student participates in and his or her grade point average is close to 0. A correct interpretation of the statement would be, so right off the bat I have correlation between the number of extracurricular activities the student participates in and his or her grade point average is close to 0. And we are asked to interpret this. So before I start that, let's kind of review what are our R values. So we know R has a minimum of -1 and a maximum of +1. In the middle, we have an R value of 0. As R moves further away from 0, either towards +1 or further away from 0 towards -1, we say that the relationship strengthens. It either strengthens in the positive direction or it strengthens in the negative direction on it. We also know that if we have -1 and we move close to 0, or we have +1 and we move close to 0, it weakens. We don't want to say the words increase and decrease on it, because if I decrease from 1, I could go all the way to -1. So we don't want to say that. We don't want to say increase because I could increase all the way to +1. So we're going to say it either weakens as it moves towards 0, or it strengthens as it moves towards 1 or -1 in the positive or negative direction. So maybe this will help us. So I'm going to read the choices. We can figure out what they mean. And let's kind of look right off the bat is close to 0. So that means, and I'll use a different color, that means I want to be around this area. So right off the bat, I can say, well, that's got to be really, 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 really weak on it. If it does have a linear relationship, it's got to be almost non-existent based off of that. So let's take a look. Active students tend to be students with poor grades and vice versa. So if I kind of mark this, active students, so the more activities they're involved in, the worse their grades. So as one increases, the other decreases. That sounds like a negative correlation on it. So I don't like that one. Students with good grades tend to be students who are not involved in extracurricular activities. That almost sounds like the one up above. If they have good grades, that's positive, then they are not involved in extracurricular. So that looks like a negative correlation as well. I don't like that one. Students involved in many extracurricular activities are just as likely to get good grades as bad grades. So it's saying it doesn't matter on it. That's an interesting one. I'm going to put a little dot next to it so I can read that in more depth after I try and eliminate more. There is no linear relationship between the number of activities and grade point average for students at this school. Well, if I'm looking at this, that looks like a reasonable choice to keep there. And E says involvement in many extracurricular activities and good grades go hand in hand. That sounds too much like cause and effect to me. Is they go hand in hand. That's a positive correlation, but you're trying to draw a conclusion from it, and you can't from observations. So it's either C or D. If I want to figure out which one's the best answer for it, if I'm asked to interpret my R value, I mean, our R values are used to determine not only is it a positive or negative correlation, but what type of linear correlation we have, a positive linear or negative on this. We can really kind of, I'm leaning towards D. C sounds too much. Students involved in many extracurricular activities are just as likely to get good as bad. But it makes it sound like there's no relationship, which you can kind of maybe think that sounds like this. But it does sound like too much cause and effect on there, that it doesn't matter which one you're involved in. I think the correct interpretation, if I want to interpret R, you are trying to determine the strength of the linear relationship for this case. So the correct answer here is going to be D. Now look at number 2. The British government conducts regular surveys of household spending. The average weekly household spending in pounds on tobacco products and alcoholic beverages for each of 11 regions in Great Britain was recorded. A scatterplot on spending on alcohol versus spending on tobacco is shown below. Which statement is true? Let's pause. I underlined the spending on alcohol versus spending on tobacco to highlight a point. Remember, we explained before in class, and I want to bring it up again. When you see the word versus, we have our y versus our x. We have our response variable versus our explanatory variable. Now, I know we can see that from our graph that tobacco is the explanatory variable, alcohol is the response. But if they didn't give us the scatter plot, we have to be able to remember that from the prompt itself. So which of the following statements is true? Let's go through. We're going to have to read and eliminate and try and go through which one's the best answer. So 4.56 looks like this point. Is it an outlier? Well, if I'm looking at the pattern, it looks like it is a linear relationship you can draw in there. It looks like it's positive for it. Doesn't look like it's too much of an outlier compared to the others. That's a estimated line of best fit from it. And it doesn't look bad. I mean, at this point, it looks more like an outlier, or it looks like something way off from the others. So that's not 4.56. I think 4.56 is in the same general path as the others. So I don't think the answer is going to be A. There's clear evidence of a negative association between spending on alcohol and tobacco. Well, I erased it, but I kind of drew my line at best fit, the estimation. That looks like a positive association, so I'm not going with B. And so now C, the equation for the least squares line would be approximately your predicted value, y hat is 10 minus 2x. So let's break this down. Our y-intercept is 10, and the slope is negative 2. Now I could analyze both of these. My y-intercept 10 wouldn't even be on this graph. It would be way, way up here. So I don't think that looks right, but I wouldn't cancel out for that. I really focus on this. A slope of negative 2 for your least squares regression line would mean a negative correlation, a negative association, which is the same thing we canceled out in B. So the slope itself tells me that there's no way it could be C. The correlation for these data is 0.99. Well, that is positive. So it's got that going for it, but 0.99, I mean, that's right about here. If I use that graph from before, that's a very, very, very strong positive relationship. When I sketch this, it's not linear path. They're not all tight around that line. They're spread out around it. So that doesn't look like it's really, really, really strong for it. So I don't think the answer is going to be D. That doesn't mean I should write down E right now. I should read E and make sure it's better than D. The observation in the lower right corner is influential for the least squares regression line. Well, again, I keep on erasing, but we'll put it back. There's my estimation. Well, this point is going to be influential. It's pulling down that slope on that line. If I were to erase that point, if I were to get rid of it, the least squares regression line, the R value would get stronger on it. So I think the answer in this case is E. That is a very influential point on it. And it's far off in the Y direction from the least squares regression line. It's going to affect the correlation. Number 3, the fraction of the variation in the values of Y that is explained by the least squares regression line of Y and X is. Before I start though, I mean fraction. I don't like that word. I want to think of another word that means fraction. 3/4 is 3.75, which is 75%. So when I see the word fraction or I see the word ratio, I'm going to think of the word percent. on it. So let's read with the word percent. The percent of the variation of the values of y that is explained by the least squares regression of y and x is, well, that's not like a definition. So let's try this out. Is it the correlation? Well, correlation is between -1 and 1, like with the picture above showed. So maybe there's a chance. So we'll keep that one. The slope of the least squares regression line, that doesn't seem like the interpretation of slope. That the y values can increase by the number for every 1 unit of change in the x direction. That doesn't look like it. The square of the correlation coefficient. So the square of the correlation coefficient. So in this case, they're talking about r squared, which r squared is 8% because it is going to be between 1 and -1. You square those. So I like A and C. I'm going to keep A and C right now. The intercept of the least squares regression line. Well, that is when our y-intercept for this, we have a x value of 0. So that interpretation was what happens when you have no values in the x unit. It doesn't look like it's the interpretation of the y-intercept. Residual. Well, residual, a basic definition is it's the actual, what you observed, minus what you predicted on it. It's that distance from it. So I don't think it's residual. So it's either A or C. Well, correlation is your R value we said. It really is used for direction and strength. The square of the correlation coefficient, well, the square, least squared regression line, that's your R squared. And this is, if you were to look at it, the interpretation of R squared on it, just without the context for it. So R squared tells us the percent of variation in the values of y that explained by the least squares regression of y on x. R tells us the direction and the strength of a correlation. So this is a good, what's the difference between R and R squared? Number 4. An AP statistics student designs an experiment to see whether today's high school students are becoming too calculator dependent. She prepares 2 quizzes, both of which contain 40 questions that are best done using paper and pencil methods. A random sample of 30 students participates in the experiment. Each student takes both quizzes, one with the calculator, one without, in random order. To analyze the data, the student constructs a scatter plot that displays the number of correct answers with and without a calculator for each of the 30 students. A least squares regression yields the equation shown. Which of the following statements is or are true? So it's one of these problems. We have to go through and figure out which ones sound true and false and kind of go through it. So if the student used calculator as the explanatory variable, the correlation will remain the same. And this is important because calculator right now, when it's the predicted, is the response variable. And the paper pencil methods are, for this case, the explanatory variable. Now, we've learned before, and it was said that it doesn't matter which one is your explanatory or your response, the correlation will remain the same on it. So I do like 1. So I'm going to go through my choices. So right now I might eliminate B. I might eliminate C. I'm going to read them first, though, but I do like 1 for it. So if the student had used calculator as explanatory variable, the slope of the least squares regression line would remain the same. And so when you read that one, you're going through and thinking, well, it might sound similar to the first one. But let's look at an example for this. Is if I do 1 based off of calculator up here and the pencil down here, it's got a negative y-intercept, a positive slope, so I'll just do this. And what if I flip them on it? So I put the pencil here and the calculator here. Is the slope going to be the same Well, slope is delta y over delta x. So this is the calculator over pencil. Now they're both low. They're both out. They both get higher too. So it does, well, it looks the same, which again kind of makes me see this one. Well, is the slope the same though? No, I'm sketching this by hand, but in this case, slope's still delta y over delta x. But in this case, it's the change of pencil over the change of calculator in basic terms. It's pencil over calculator, which in this case is the reciprocal of this. So I really don't think it's 2. The correlation would stay the same, but the slope would change because your variables are trading places. So the x and y variables would flip with the slope. So I don't like 2 at all. So I'm going to get rid of anything with 2 in it. I've just disproved it just by drawing this and kind of labeling. I didn't even look at any numbers. And I didn't even need to see the pictures. I just used it to kind of show that they trade spots here, so they're going to trade spots here as well. So let's see 3. Because if 3 is true and 1 is true, it tells us it's D. But if I can distinguish between 3 and 1, then I know it's A. The standard deviation of the number of correct answers on the paper and pencil quizzes was larger than the standard deviation on the calculator quizzes. So now we have to think about this. I'm given a predicted value, I'm given a y-intercept, I'm given a slope, and I'm giving r. So here's what we know. So let me get rid of this because we've already eliminated those on it. We know that b, our slope, equals r times the standard deviation of the y over the standard deviation of the x. So let's take a look at this. The standard deviation of the number of correct answers on the paper pencil quizzes was larger than the standard deviation on the calculator quizzes. So we have here on the bottom is the standard deviation of the pencil quizzes. And on the top, we have the standard deviation of the calculator quizzes. We know our R value. It's 0.79. And we know our slope is 0.865. So is the standard deviation of the number of correct answers on the paper pencil quizzes larger than the standard deviation on the calculator quizzes? Well, if I go ahead and calculate this, and I want to solve for this fraction, the standard deviation of the calculator over the standard deviation of the pencil, maybe that will help me on it. So when I do this, I'm going to divide 0.865 by 0.79, which is close to, we'll do approximately 1.095, which you think, how does that help me? Well, if you're taking a number and dividing by another number and you get 1 point something, this number is bigger than this number on it. The calculator standard deviation has to be greater than the pencil standard deviation. So let's read this. The standard deviation of the number of correct answers on the pencil is larger. Well, we just disproved that. And this 3 was harder on it because I didn't find an exact answer to prove it. I had to remember we had a formula that compared standard deviations with each other for both variables, s of y, s of x. And I was able to plug in and solve for those, but I had to interpret my result. You know, what does that mean to have the standard deviation of the y variable over the x variable being 1.095 or close to 1.095? Well, it means that the standard deviation of the y is bigger than the standard deviation of the x because the number is greater than 1. So the value on top has to be bigger than the value on the bottom. So that eliminates 3. So this one is tougher. A lot of students would probably lean towards saying threes, right? Because it sounds nice. But you have to take your time. A lot of multiple choice questions, you have to walk through them and at least try something, not just read it. There's sometimes some multiple step ones. I did say this video is going to go for questions 1 through 5, but it looks like 5 is attached to 6. So I will do a separate video of just 5 and 6 because I really do like these two questions together. But this hopefully helps you with questions 1 through 4.